Hello everyone. In this video, we'll talk about one last and final and one of the most popular dependency breaking technique called dependency injection. In this video, we'll discuss how we can use dependency injection to make our class easily testable and our code base more maintainable. So let's get started. So if you are having some hard time around this subclass and override, or you feel overwhelming doing it, there's another third technique which is very common use across many design pattern in order to test it, is basically called dependency injection, which is basically called DI, and there are a lot of framework around it on how you can manage it. The reason why it got so famous is because you can replace that dependency in test and you can figure out the graph of your dependency very easily compared to having this global static method and subclass and override technique. So how do we do that? Let's first revert what we have done so far. So we'll just remove this test home screen and just go to the home screen, and as we did with subclass override, we move that variable on our top in order to easily fake it in the test, and we override it. But in dependency injection, instead of overriding, we just inject that dependency into a constructor. So what do I mean by that? For example, since we are getting the app dependency.get here, in DI world, what we'll do is we'll just create this as a variable, and then we'll have a constructor which takes the app database, and then this will be used across all that. So I'll just replace this with directly a getter, and I'll just make it final here. So instead of getting that from overriding the method, we'll just inject directly into the constructor, and that is what all dependency injection is. There's a lot of framework and design patterns and a lot of things goes on, but it's just basically injecting your dependency through a constructor. So your class does not care about how this app dependency is created, it just gets injected to its home screen. Now let's just go to the test, and now it required home screen dependency everywhere. This won't be an issue if you are having a lot of this dependency in a test. You can basically easily pass everywhere the database here, but the problem is that this won't be a real case in your app. This home screen might be used a lot of places. For example, if I use a home screen here, it's used here on my app, and here it does not have that dependency and it's giving a compile time error. So to avoid that, what we can do is we can give a default behavior to a constructor. When the dependency is not passed, it should know a default way of getting it, and then in test you can replace it. So for example, here what we'll do is, instead of making this as a required parameter, we'll make it optional, and we'll initialize this app database. So if this app database is null, then get the app database from here, which is the usual way which we are doing it earlier. So what we are telling here is, if you get an app database here, just use that. If not, then use the app database.get. Now this will remove our compile time warning here, because since it's an optional, and if we are not passing, it will get actual database which we want to be in a production, and then if we pass this, we can fake that. So for example, if we go inside test, now it's not giving a compile time error because we have made it optional. Now since we want to have a fake database here, what we can do is I can just use the app database and pass fake app database, and if I run test, it passes. And now just let run all the tests, and it works as expected. So what is happening here is that since we are not passing the default home screen, it will get this database, the actual database, but if we pass here the database, it will take that into consideration. if someone came across this code, then if they are confused with what we are doing with this, we can just add a comment here that this will be backward compatible with all other dependencies. So this dependency injection is a very powerful technique, and you can use pretty much across all the code base, making the legacy code testable. Just few word of caution that since this class will be used by a lot of many other places, just have a default way, or basically have a fallback for that optional parameter, that if it is not present or it's a null, then you need to find a way to get the actual database. And from my experience, the majority of the test issue can be resolved with the last three technique which I explained, which is basically replace the static method, subclass and override, and dependency injection. This is the three technique 80% of time I use whenever I want to write tests, but there will be some edge cases where this three won't work and you need to find some alternative way of doing it. Now, since we wrote two cases where we are just testing the title and the project name, since our target was to make all the test cases for the home screen coverable by test, so now we'll run the code coverage tool and see how we have done so far. So what I'll do is I'll just run the Flutter test coverage, and then I'll just generate and open it. Now see that we have increased our percentage to 12.3. If you go to the home and you see, now earlier we were using 33% of test coverage, but since now we have tested the item in a list, we have increased our code coverage to 51. So you see we have now able to test this method which was not there earlier. We are testing this task row now, and you come across task row, you'll see it also use 91% of code, because since we are running this in a test. So by just running one test, we are basically covering a lot of classes. But few things you need to understand why we are tracking this is because once we get into around 90 or 100% of a test coverage, we can refactor this code very safely, because we have now tests which cover all the cases on this home screen, and refactoring with those tests will be really helpful, and it will work as a safety net for us. To conclude this video, start with a simple test like having a task added here and just showing one item. And then if you find some repetitive code, just extract that into a utility like this we did for wrapping with material app, and use the three techniques which I have described to write a test for a complex scenarios. Basically replace static method, subclass and override, and dependency injection. And one thing is that which I learned across the code base, that since we are using a fake app database and this was just a single dependency, but try to use real implementation as much as possible. Fake it only when you actually need it, because a lot of fake and mock also lead to undesirable behavior. So if you mock something, but if you have changed the method, it will make your test still pass, but in real implementation it fail. So just rule of thumb, try to use a real implementation as much as possible, until and unless you are stuck and need to fake some dependencies. As we have seen in the task here, we have a row task which is basically 91.1% tested. So I think this is a good candidate that we can refactor here some stuff, or we can add a new feature here. In the next video, we'll add a new feature in the existing system and make sure that how the new changes we have made is also covered by test. So see you in the next video, where we will cover how to add a feature to an existing app without breaking the app. So if you like this video, then please like, share, and subscribe. Thank you.